In software reliability, we are taking question and answers. We'll take some MCQs and also the numericals. Reliability of a software is directly dependent on. Before that, let me show you or tell you the IEEE definition of reliability. So software reliability is a probability, and this is defined as the ability of a system or a component to perform its required functions, to perform what it is being designed and made for, under the stated conditions for a specified period of time. That is, if a software is made or system is made for certain function, the software reliability is whenever you require it, it performs that action under specified condition for a specified period of time. This is reliability. Now, if it is working, that is, you can rely on that particular system. So now let us come back to the question. So reliability of a software is directly dependent on what? And there is no problem. That means there is no errors. The answer is 2. And one more thing about software reliability is that reliability denotes the trustworthiness or dependability. Or you can also say that reliability is the probability of the software product working correctly over a given period of time. So reliability is probability of a product performing correctly or performing all the functions correctly for a given period of time under stated conditions. So from these all discussions, the answer is 2, number of errors present. Now you'll see 3 questions same way. Answers are same. So the reliability of the software is directly dependent on what? Now you can answer. See, reliability, that is a software product having large number of defects, is unreliable. So whenever you remove these defects, the reliability increase. So the answer here is number of errors. The reliability of the software directly depends on number of errors. Same question with different twist. Reliability of software is dependent on what? Defects. Because more defects, unreliable. Less defects, more reliable. Because reliability increases if the number of defects are reduced. So again, the answer here is number of errors present in software. So the first is the correct answer. Number of errors, defects present in the software. Software development life cycle has following stages. The first thing is the requirement analysis. That is, here you create the SRS, software requirement specification. Then you design, you prepare the design documents. Then you code or coding you do. Then finally you test the code. So 1, 3, 2, 4. Do you find any of the option? No. So the answer is none of the above. So the software development life cycle, depending upon which software processes you are using, agile or say spiral or incremental, prototype, waterfall, whichever you are using, basic idea remains the same. That is planning, analysis, design, implementation, testing, integration and maintenance. So these are the different stages, phases. So none of these is the answer. Which of the following tools is not required during system analysis phase of SDLC, software development lifecycle? So in SDLC, as I just showed you, there are proper phases. In every phase, we create new document. There are work products being created. So case tool, computer aided software engineering required, rapid application development tool required. Reverse engineering is not required because reverse engineering is a part in implementation, and reverse engineering is one of the part of software re-engineering. Okay, so when reverse engineering does, that is only done when the old code is not, the old system is not available, the documents are not available, and the support is not available. So there are only the cost of change is can be done because the cost of software change will be very high, so maintenance can be done only. So from code you go back to specification via the design, and finally you do the forward engineering. Which of the following is not a key strategy followed by the clean room approach to software development? Now, clean room is really like a clean room. There is no dust. That means when you make the SRS, it can be validated through mathematical, algebraically and other means. That is, there will be no ambiguity. Whatever you have written in English, sometimes it is different for you, different for me. But in clean room approach, everything is done mathematically, proven and statistically. There is no empirical thing. Everything is unambiguous without any anomaly. Okay, most of the time you cannot get that, but this is an approach. So if you see this clean room approach, first we formally specify system, and then we define the software increments, and there are program being constructed. We formally verify the code, integrate the increment, test integrated system, then we do the design test, the statistical test. All these are done. All you see in the diagram. What you don't see here, dynamic verification. So the answer is number 2. Key process areas of CMM level 4 are also classified by a process which is. Let me show you the CMM first. Capability maturity model. So you can just remember is like IMDQO. Initial, managed, defined, quantitatively managed and optimized. So this second managed also sometimes people say it is repeatable. So it is just said IRDMO, that is initial, repeatable, defined, managed and optimized. Okay, so now you see here the question is key process areas, these are functions of CMM level 4 are also classified by process switches. Please remember, whenever you are on certain level, the below level you have already attained. So when you are talking about level 4, the answer is 3. Because level 4 and level 5 have the difference that all the level 4 are done in level 5 along with the performance enhancement. That is performance enhancement and the improvement, continuous improvement, also using the mathematical, statistical and other things. Validation means. Now the question, this is always asked, what is the difference between validation and verification? So verification and validation. Now you made a code of add. Now whether this function is actually adding the numbers, this is verification. This is verification. Oh, this code is working fine. But this add function is actually required by the user. That is validation. It's so simple. So verification is the system correct to specification. Validation is this the right specification? That is, the validation is always done with respect to the SRS, that is what user and you have agreed. And the verification is done with respect to the design document, with respect to different tests, like the unit test, like the integration, like regression test, all these. That is verification. But validation is always, acceptance test, the final alpha beta test, like that. Acceptance test contains this alpha, beta, etc. So here the validation includes the usability testing, user feedback. So user is always involved because it is with respect to the requirement specification. Verification, it includes all the testing done by the software team or the developer, like the inspections, the reviews, the static analysis, the dynamic analysis, like this. So this validation is, are we building the right product, that is the product which is right for the user, which is required by the user, which is given in your SRS, which is proven in SRS. What is the first stage in program development? First you need to understand whether you are going to make what it is this. So the answer is system analysis. Then only you can design, then only you can test. Software engineering is a discipline that integrates dash for the development of computer software. In software engineering, everything is there, process is there, methods are there, the tools are there. So the answer is all. ALL. Fourth is the answer. In software development, value adjustment factor include the following among others. So in order to understand this, first you have to understand what is value adjustment factor. This value adjustment factor comes under the function point analysis, FPA. In function point analysis, for example, you might have been doing this KLOC stuff, kilo line of code. In FPA, we actually use it for the project estimation, the effort, the time, that is the duration, and the cost. So this FPA gives you a number, how many functionalities the software or a system is going to provide. For that we need this, but we need certain value adjustment factor also, because there is a whole formula of computing it, and we need this 1 to 14 value adjustment factor. So if you see here, there is reusability. So the answer comes first one, the criticality of the performance and the reusability of the code. In clean room software engineering, clean room, I told you about this in the previous question. So only eco-friendly, no. Only high-end facilities, no. Correctness of the code is verified before testing, yes. Implementation is done only after ensuring correctness, yes. But in the third and fourth, what is the correct answer? In clean room software process engineering, we make SRS so that it is unambiguous, it has no anomaly. So here it comes, implementation is only done after ensuring the correctness. Okay, so once the different formal verification, validation, there are different methods we use, but implementation is done only if things are correct, otherwise not. So this is the answer fourth. Correctness of the code is verified before testing, no, it doesn't fit here. So SRS is unambiguous here. It is properly formulated with mathematics, with algebra, with various other stuff. An error message produced by an interactive system should have. Now if there is a system, there is a software, some error comes. As a user, what do you want? For what this error has come, what I have done, and what should I do to remove this error? Or what is the say bypass for it, or other way? So the answer is the list of mistakes done by the user is displayed. The answer is 2. This is called a good error message. System development cost estimation with use cases is problematic. We already seen that the KLOC, kilo line of code, is the best metric of sizing. The FPA is the best metric for sizing. Use case also we can use. But here the problem is use case making is you and me, we are making. So for a banking system, you can make a different use case, I can make a different use case. So the problem here is the data can be totally incorrect, because the input, there are formulas, there are expressions, empirical expressions that we can use for the estimation process, project estimation. But what is the input? If it is not correct, what we do? So this is how we compute the UCP, use case points. We use UU sub CW, UAW. There's a whole discussion about that. You can just go and see. These are TCF, EF, some environmental factors, some working factors. Ultimately, the point is the data should be correct. If it is incorrect, use case points have no meaning, no value. Which of the following tools is not required during system and analysis phase of system development lifecycle? We already discussed this and we just talked about that. Reverse engineering tool is not required here, because the reverse engineering is all about when you have a code, you don't have any support. The only idea is to maintain the software rather than changing the software. So you start with the specification, go back to the with the code and go back to the specification. Then you do the forward engineering from this specification. You make the code. A new system is designed. In software development, UML diagrams are used during. Now this is a very, very tricky question. Everyone thinks that the UML is unified modeling language. So modeling is all about design. Okay, whenever you are going to make your house, you are going to make model. So that means in the requirement phase, it is not required. But the answer is UML is designed for each phase of the software development lifecycle. So it starts with the analysis, requirement specification, then design, then testing. Everywhere you can use it. So I'm just trying to show it here. You will not be able to see properly, but still, this is just to show that everywhere you can use UML in the whole SDLC, software processes. UML is the key now. Answer is all the given options. A design concept refinement is see, it's all about, actually design concept refinement is nothing but elaboration. So you're talking about abstraction, going to different level of abstraction, that is from high to low, and also the refinement, that is refinement is elaboration. So the answer here is fourth one, all of the above. So you're going from top to bottom, top-down approach. You are actually, this is a complementary of abstract concept, which I just showed you, and process of elaboration, you are actually extending it. So you are extending the design concept. So this is the refinement, nothing but abstraction, refinement, going top to bottom approach. So the answer is all of the above. A black hole in a DFD is now DFD is a data flow diagram. Now this, you see a diagram here. Assume it to be data store. Now you see that it has only inbound flows. There is no output. That is called the black hole. So black hole, a data store with only inbound flows. A server crashes on average once in 30 days. That is, the mean time between failure, MTBF, is 30 days. So MTBF is given in the question, 30 days. When this happens, it takes 12 hours to reboot it. That is, mean time to repair is 12 hours. MTBF 30 days, MTTR 12 hours. Now since it is in hour, you have to convert, so days can be converted into hours. The availability of server with these reliability data value is approximately. So availability is MTBF divided by MTTR plus MTTR plus MTBF. So this days needs to be converted into hour. One day 24 hour. You just multiply it by 24. You will get some 720 number, I guess. So the answer is third. If you want to try, you can try. I'll just show you how to do this. See, 30 days, we have converted it into 720 by multiplying with 24. One day has 24 hours. Now we have hour. Now MTBF is 720 divided by 720, which is MTBF, plus what is the MTTR? That is called 12. So the answer will be 98.36%. It will come 0.9836 in percentage wise. It will be 98.36. So this is the answer. A program P calls two subprograms P1 and P2. P1 can fail 50% time and P2 can fail 40% time. The program P can fail. So this is a set theory example actually. So here we have a program P calling subprograms P1 and P2. So the probability of P1 failing 50%. So this is 0.5. 50 by 100 is 0.5. P2 fail 40% time, so it's 40 by 100, that is 0.4. And now the program P can fail. So either P1 fails or P2 fails, you can just add them. Or if they fail together, now this is already included in P1 plus P2. So P1 fails, P2 fails, if you combine them, there is that probability is also including the combined probability of P1 and P2 failing together. So P1 plus P2 minus intersection of P1 and P2, you have to remove it from P1 plus P2. So what do? P1 union P2 you have to find out. So 0.5 plus 0.4 minus the multiplication of 0.5 into 0.4. So we are just saying that 0.4 into 0.5, why we are multiplying it? We are assuming that P1 P2 are independent, mutually exclusive. So this is the answer. I'll just show you here. Let me clean it. Formally, if you are actually doing it, then you just see how to do this. Stepwise, you have to manufacture it. So you have 50 by 100 P1, 40 by 100, that is 40%, and the subtract mutually exclusive 50 by 100 into 40 by 100. So what do you get? The answer you get is 70%. 70 by 100 is 70%. So the answer is fourth one here. Assume the following regarding the development of a software system P. The line of code is 33,480. Average productivity of P is 620 line of codes per person month. Number of software developers 6. Average salary of software developer 50,000 per month. If E, D, C are the estimated development effort, estimated development time, and estimated development cost. So E is effort, D is development time, C is cost in lakhs. So how do we compute this? Now I'll tell you a different method. If you have done it already, it's okay. I'll do it only by using the unit method. I'll just see the units and then I'll try to find out. Sometimes confusion may happen. The best way to remove or avoid that confusion is to use the units. The answer here is second one. How to get this? Estimated line of code is 33,480. This is line of code. Productivity is 620 LOC per person month. Developer 6. Salary 50k. Estimated development effort. Please remember, effort will always come in person month. Person month. Person month, how do we get it? See, this is 33,480. This will be in line of code. If you divide it by 620, that will be 620 line of code per person month. So 620 LOC per person month divided by person month. Person month will go in the numerator. LOC get cancelled, so you'll get it person month, and person month means you're talking about effort. So effort can be computed by division of these two, that is going to come as 54. Okay, so this is 33,480 by 620, 54 person month. Now second thing you need to know or find out the development time. Now you need time. So time is, see here, person month. 54 is person month. Now if you can divide, if you can cancel person from here, you'll get it in months. How many persons are there? 6 persons. Cancel this. 54 by 6 is month. 9 months you need. 9 months. Now what? I'm not seeing anything. I'm just seeing the units. Next is step 3. That is the cost. Cost is very simple. 50k. You know that it is going for 9 months. How many people are there? 6. So 50,000 into 6 people into 9 months they are working. The cost will be 27 lakh. Please remember, 10 lakh is 1 million. So if you know in a million, this is the answer. So the second one is the answer. Our software project has estimated 352 function points, FP. Function points are 352. These are number of functionalities or the functionality being provided by the software product. A 4-person team will be assigned to this project consisting of an architect. 1 is architect, 2 are programmers, 1 is a tester. The salary of the architect is 80,000 per month. 80k. Programmer 60,000 per month. Tester 50,000 per month. The average productivity for the team is 8 FP per person month. 8 FP per person month. So 8 FP per person month. 352 FP is already there. So by unit method also you can do. Which of the following represent the projected cost? So in order to get the cost, let us see. I've already told you about these function points and we discussed that in detail. So 352 is there and this is in function point. The unit is function point. So how many people are there? 8 FP per person month. So if you divide by 8, and since there are 4 persons and 8 FP is the delivery for 1 person. And in 1 month, 1 person, 8 FP. And there are 6 people. The answer is this one, 4th one. So okay, let me do it again. This is 352, 4 and 8. So 4 person, 1 person giving 8. 4 into 8 is 32. Divide 352 by 8. This 8 for the 32. So this is basically you are dividing the function point because you need to find out the months. So function points divided by the team average each person's FP productivity. And you also need to know the numbers. So you have this FP by TFP. So 4 into 8, 32 it is. 352 by 32 is going to be 11 months. These are the total number of months. Now salary is very easy. See, you know the salary of each of them. 80k plus 60k into 2 because there are 2 Two people earning this much and then 50k. Add them, multiply it by how many months they are going to work? 11 in thousands, right? You get 2750000. This is the answer. Okay, this is all about this question answer. Thank you so much.